My name is Kevin, and with my partner Francis, this is our final project, Finding a Way using Unet and filtering to find routes through mazes in campus. This project centered around the question, can we use satellite images to navigate through an environment? In part, this was inspired by the new Mars rover Perseverance and how in the future Mars rovers might use aerial images from a helicopter to navigate. Unfortunately, we couldn't test this theory on the actual rover, so we had to come up with a different idea instead.
So, what can we do instead? For our project, we'll create an image processing pipeline that would enable an entity, marked by the blue dot, to find an optimal route to a desired location, marked by a red dot, using only aerial images. For our approach, we'll be using raw satellite images as an input data and identify roads from either a classification or a segmentation technique. To detect roads in satellite images, we have three main methods: edge detection, classification techniques, and Unet. For edge detection and classification techniques, we ran into issues. For edge detection, we could find the boundaries between roads and non-roads. However, we couldn't tell what was a road and what wasn't a road. For our classification technique, we could find patches of roads in the image. However, as you can see in the output image on the right, the patches were not continuous. With these limitations in mind, we decided to use a Unet, which would utilize spatial information in conjunction with pixel value information. The Unet is comprised of an encoder and decoder path. The encoder path has several convolutional layers, in addition to pooling layers. Each of these layers converts features into a lower dimensional feature space. The decoding path takes the output of the encoding path and upsamples it. In each subsequent convolutional layer in the decoding path, we concatenate the input with low dimensional features from the encoding path. Our output is an output segmentation map that gives us pixel-wise classification for roads and non-roads.
After we implemented Unet, we were able to look at the segmentation masks that it had created to identify where roads were. Unfortunately, these weren't appropriate for maze-solving tasks, so we decided we needed to do some post-processing on this data. And the two big things we needed to do were to decrease the search space for our maze solver algorithm, and then correct some of the discontinuities to make it so you could find a continuous path along the roads. So the way we did this was by using a series of different deterministic filters. First, we thresholded the image to figure out where roads could be. Then we applied a Gaussian blur to smooth out all of the edges of the roads and fill in small gaps. We then downsampled to make the entire image smaller. We thresholded again and then applied some logical operations that would go and fill in small holes if there was a road on either side of them. Once we did that, the entire maze was saved as a text file, which we were then able to read in the user-supplied start and end locations, which then created this maze. The text file, you can see sample 1 on the top right, and then the maze is actually on the bottom right. Once we had the maze, we actually had to solve it. And the way we did this was with an A-star search algorithm, which pseudocode for that is on the right side. Essentially, it decides where it's going to search based off of a heuristic, which is the sum of the current distance it's traveled and then the Manhattan distance from where it is to the goal. And this was always guaranteed to return an optimal route for us. And once we found that route, we had to upsample it to undo our downsampling operation, then color it and display it onto the original image. So with that, that concludes our presentation. We're now going to do a live demo of our code. Okay, so now we're going to do a quick demo of our code. So we can run this file, and what it will do is display an image where we can select a start and end location. And what it will produce is the original image with the start and end location, our Unet output, which we've already computed the Unet output for the purposes of this demo, but this is the Unet output and then the route that is found using this Unet output and overlaid onto the original image. And what we can do is we can repeat this same process with a different file and show that we can select an arbitrary different start and end location. Maybe we'll pick here and down here. And what we'll get is the same types of outputs, but with this different Unet mask and this different original image, so we can get a different route.